Hello, evening, guys. Uh, Happy Monday, right? Good evening. We meet again. This is our May week 4, the last week of May. You messed up your blast furnace. What do you mean? Is that a game or something? Why do you have a blast furnace? Or you mean your exam? Oh, label. Wow, funny you should mention that. I was just teaching about blast furnace just now to my Form 3s. Which part you labeled wrong? Which part you labeled wrong? Oh, iron ore, right. What did you write? What did you write? So you need iron ore, coke, and limestone. So which one did you write? Which one did you get it wrong? Oh, you put in the side. Oh, the side is CO2. The side is hot air. Ah, yes, I mean, common sense, you just add all the raw ingredients at the top, so as they sink to the bottom, you get pure iron. Okay, you get molten iron. So anyway, okay lah. Things like this you'll get it wrong once lah, then you will get it wrong again lah. Okay, usually it's that way. Right. So today where were we, huh? Where were we, huh? Okay, let's finish this pressure thing, shall we? We have a few questions left, right? Which is this pressure one. Do you remember what is atmospheric pressure? Oh, that is cardiac muscle. Heart is cardiac, ma. Never mind. Things like this, or you'll get it wrong once and you won't get it wrong again. That's the best way you learn, right? I mean, I hate to say it, but you guys need to make mistake to learn stuff. That's what happens. Happens to me too, right? I know how you feel. Right. So atmospheric pressure, Atmospheric pressure, This is what happens when you are standing and there's air on top of you pressing on you. This is called atmospheric pressure. Right? So the higher you go, less air pressing on you, so there's lower pressure. So like I said last week, on top of the mountain where pressure is very low, your water will boil at maybe 80 degrees. But at flat ground, okay, at our normal place close to the sea, you have a lot of pressure pressing on you, water will boil at 100 degrees Celsius. Right? It's harder for water to boil because you have more air pressing on it. It's harder for water to escape into the air. Right? What does renin? Renin will change carcinogen to casein. They will coagulate your milk. Wow, why they ask about that, leh? Why they ask about that, leh? They will change carcinogen to casein. This is actually your year 10 stuff, lah. That means milk, okay, milk, they are liquid, right? When they go into your stomach, they will change into solid. So when you puke, when you vomit milk out, you'll see like solids in it. That's the casein. Oh, yeah, and wow, so fast you're learning that already, Right. So let's talk about pressure. So this is a balloon containing air. Explain how the particles of air inside balloon creates pressure. Okay, guys, how is pressure created? Pressure is created when the air particles, they collide, they bang the wall of container. Remember? Remember? So you have your air particles colliding with the wall of container. Okay, air particles banging the wall, that is air pressure. All right, so more banging, more pressure. So how do you make more banging? You reduce the volume, make the room smaller. You increase the temperature, make the air hotter. So hotter means they move faster, they bang harder, so higher pressure. So number B, the air in the balloon is heated up by living in a warm place. Like I said, give two effects that this has on the air particles. So what do? They will travel faster. Okay, they will travel faster. They will collide more often with the wall of container. So they bang more. Okay, they bang more. Collide more often. So C, describe one way in which the balloon changes when it is left in a warm place. Okay, so when you leave it in a warm place, your pressure will increase. Pressure increase, the balloon becomes fuller. Higher pH, that will be alkaline, right? That will be alkaline. So which one is a strong alkaline? I would say NaOH. NaOH is a stronger alkaline. MgOH doesn't even dissolve in water. MgOH doesn't dissolve in water. NaOH, NaOH is a alkaline. MgOH is a base. Why die? Don't die yet. Don't die first. Hi Renee, how are you? Never mind, things like this you get it wrong once one. Okay. Hey, Carl, your school is learning that fast, huh? You're already in year 10 stuff leh. Most of the stuff you ask me is actually year 10 leh. Wow, so fast you're learning it. Okay. Why NaOH not used in antacid? Because they are too high in pH. They are too alkaline. They are too alkaline. They are strong alkaline. That's why we don't use them. Okay. Hi, Junie. Good evening. Hey, guys, quick announcement. Since everyone is here. Since everyone is here. Next Monday, class is still as normal. Next Monday, class is still as usual. Right? We, TDC, we don't have public holiday one. We just have our term break. Our Monday class still goes on as usual. What holiday is it anyway? Is it some, I think it's Sultan's birthday or something. So whatever it is, whatever it is, I don't care if it's Spider-Man's birthday or whatever, right? Our class is still as normal. Oh, you will be absent. Okay, then make sure you request video. Make sure you request video. Right, so anyway, we are in pressure, guys. Last week stuff, let me finish this before we go to the next chapter. So number 10, the diagram below shows the condition of air molecules in a closed container. So this is, all these are air molecules. The condition of these air molecules produce air pressure. Okay, so they collide on the wall, they bang the wall, they create pressure. So how is air produced? How is air pressure produced? Okay, so how do you create air pressure? When the air particles, again like just now, collide with wall of container. They actually gave you the answer in the question though. You see, air molecules hit the wall of container, right? More hitting, more banging the wall. This is the air particle. More banging, higher pressure. Again, how do you make more banging? You can reduce the room, make the room smaller so they bang more, or you can increase the temperature, make them move faster so they bang more. So two factors are volume and temperature. Very important, guys. This part is very important, because next year, sorry, not next year, next year, when you go to year 10, when you go to gas law in physics, you'll be learning the same thing. But in much detail, okay, in much detail. You have Boyle's law, you have Charles' law, you have pressure law. So please understand this. This is the basic, because next time you'll be learning it in more advanced way. Does pulmonary artery have a valve? That's a very good question. Yes, they do. It's called a semilunar valve. Okay, semilunar valve. Right, so B, then the container is placed in a hot place. I see when you increase the temperature, explain what happens to the pressure increase. Okay, why does it increase? Because the air particles, they collide more often with the wall of container. More collision, more often, more banging, pressure higher. Okay, it's a semilunar valve. Right? Aortic valve. Okay. Actually, the aortic valve, you can call it semilunar valve too. They are both semilunar valve. They are both semilunar. I just call it semilunar valve. Right, so see, if the volume of the air in the container is reduced, so now I make the room smaller. Does it change the air pressure in the container? Of course, yes. Okay, why? Because again, there's more collision. It collides, same, you can write the same answer. It collides more often with the wall of container. So more collision, so you have higher pressure. Okay, guys, very easy. Think of pressure as how to break your balloon. How do you make your balloon break? Okay, how do you make your balloon pop? Number one, you squeeze it, you make it smaller, you decrease the volume. Next, you heat it. You heat it, you increase the heat, you increase the temperature, so they will pop. Understand? Understand? Very easy, huh? Very easy, huh? So, number 11, this is your atmospheric pressure. Jasny and his friend joined a hiking expedition of Mountain Kinabalu. Guys, who has higher pressure here? Who experience higher atmospheric pressure? Is it R or S? R or S? Right? R, guys, R. Imagine this is the atmosphere. You have this much air pressing on R, and you have this much air pressing on S. You see, much less air, so much lower pressure. Right? You guys listening? You guys listening? I know it's a holiday lah. Right? Are you guys having holiday? Are you guys having holiday? If you follow normal school holiday, then you should be having school holiday now, isn't it? Oh no, okay. Then that means your school doesn't follow lah. Oh, you still have BM exam, damn. Right. So compare the atmospheric pressure at R and S. So the pressure of R is higher than S. Don't write it this way in exam lah, I'm just cutting it short for you. Pressure of R is higher than S. Okay, please complete your answer in the full sentence form. Please do not write it like this. Next, B. Based on the principle of air pressure, explain the condition faced by Justny at location S compared to his friend at location R. Right? So explain why is the pressure here lower, right? Because altitude of Justny is higher than his friend. Okay, I want the word altitude. That means how high the mountain is. Solving inequality. What? Right, the altitude is higher than his friend. Right, so the higher the altitude, the lower the atmospheric pressure. The higher you climb, the lower your pressure. Okay, Okay, That's why fighter pilots, right? Do you watch Top Gun? Do you guys watch Top Gun? Okay, do you watch Top Gun? You see fighter pilots, right? Why do they need to wear a breathing mask? Because the pressure up there is so low, they cannot breathe normally. That's why they wear this mask here. Right? So cool, right? So cool, I mean, anyone here wants to be a fighter pilot? That's really cool. Right, so C, state the relationship between altitude and atmospheric pressure. Okay, we just said it. The higher the altitude, the lower the atmospheric pressure. So that's why when it's high up there, it's very hard to breathe. It's very hard to breathe. Oh, guys, did you know this? Many athletes, okay, many athletes, few months before their Olympics, they will move to a higher mountain to live. Right? They'll move to a higher mountain to live because it's harder to breathe up there, so you produce more red blood cell. Remember this? Remember this? I think I mentioned this in the heart chapter when we learn about the heart. When you're living up there, when you're living at a very high place, you have less air, it's harder for you to breathe, so your body will compensate, but your body will solve this problem by producing more red blood cell, so you can carry more oxygen, so you have more stamina, right? So that's what they do before they go for Olympics. So the diagram above shows the same breath taken by Justny to a high altitude. What happens to the packet of bread when she arrives at a high altitude? Guys, what happens here? What happens here? When you take this bread from R to S, what's going to change? What's going to change? Anyone? Anyone? Anyone wants to answer? Anyone? Anyone? The packet will blow like a balloon. Not blow lah, okay? I would say it's inflated. The thing will be full. Right, let me explain. Let me explain. Okay, so you are living on a flat ground now, right? Any of you here living in a mountain? I don't think so, right? Okay, so say you live at sea level. You live at sea level, which is around here. When you buy a packet of bread, the bread is just like normal size, okay? Not bigger or smaller, they are just normal size. Because the pressure inside the bread and the pressure outside is the same. Let's just say your outside is 100, inside also 100. Let's say lah, I'm giving you a number to let you understand lah. So when you climb to higher mountains, let's say you climb Kinabalu, now your surrounding becomes 80. Because higher mountain means lower pressure So when your pressure is lower, the pressure inside is higher, right? So the packet will be very full. The higher pressure inside will press on the packet. That's why it looks full. Guys, you can try this next time. You can try this next time. Bring an empty bottle. Bring an empty bottle like this to your car. When your dad is going to Genting. You see, going to Genting. So the same thing will happen. Before you climb to Genting, you guys are in KL, right? Or whatever lah, wherever you are. Okay, you are in KL. So your bottle inside is 100, the pressure is 100, outside is also 100. So same pressure. Same pressure. When you reach Genting, Genting is like maybe 90. Okay, 90. So inside here will be very full, right? Inside here will be very full. So when you open your bottle, you will hear a pop sound. Okay, because the pressure escapes from the bottle. You hear a pop sound. Or even you don't open your bottle, you will see the bottle gets very full. Okay, very full. Guys, I have a question. If I reverse the thing, what's gonna happen? If I bring a bottle from Genting to KL, what's gonna happen to the bottle? Yes, it will deflate. Right? It will deflate. So if I bring a bottle from Genting, Genting is 90, right? Genting is 90. So inside the bottle is also 90. When you reach KL, KL is 100. So the 100 will press on the bottle because the bottle is 90. So the bottle will be crushed. The bottle will be crushed. So next time when you're in Genting, when you reach KL and then you see the bottle in your car, you're like, why is the thing flattened already, man? Because of the pressure difference. Okay, understand? Are you guys with me? Are you guys with me? Jihan, are you with me? Renee and Jenny, are you guys with me? Okay. Yes, cool, Right, cool. Right, so what happens to the packet of bread when she arrives? Okay, the packet is inflated. Okay, the packet becomes full. Okay, why? Because the surrounding, or you can say the atmospheric pressure is lower than pressure in the packet. Okay, so it will become full. All right, so hey guys, the same thing happens when you are taking a plane. When you're taking a plane, when your plane takes off, surrounding pressure drops, but the pressure in your ear is high. So you have this pressing feeling in your ear and it feels painful, right? You guys take a plane, you understand what I mean. As the plane is climbing, when the plane takes off and it's climbing, you will start to feel your ear starts to hurt. That's the pressure difference. So what do you do? Guys, what do you do? When you are taking a flight and it feels full, your ear is like very painful, what do you do? How do you equalize the pressure inside your ear and outside? Very easy. You just Swallow your, no need to force the pressure out. Just swallow your saliva. Just swallow your saliva. When you swallow your saliva, there's a tube here that opens, so the pressure inside and outside will equalize. So you will feel not so painful anymore. Okay, you get what I mean, eh? I hope so. Right, so next. This is it about our chapter 7. Okay, this is about chapter 7. So today, let's go to unit 8, shall we? Let's go to unit 8. This is also a chemistry chapter. Okay, a chemistry chapter. Do you remember this? Do you remember this? Oh, that's a favorite, huh? That's a good thing. All right, so this chapter is what we call element, compound, and mixture. Right, before I move on, let me write the Mandarin. Element is 元素。如果你需要华语的话啦 ，OK， element is 元素 ，compound is 化合物 ，OK，mixture is 混合物 ，OK，different guys, different okay, so let's look at the most basic first. Do you still remember what is atom? Do you still remember what is atom? So matter consists of small and discrete particles. I think you learned this in year 7 already. This is like it's like a more intermediate thing. Right, so atom, what does it mean? Atom is a Greek word that means cannot be divided. Atom is the smallest thing in the world. Just imagine the world is made up of Lego. Yes, the world is made up of Lego. That smallest Lego is called atom. Right? Because you see, when you play with Lego, right? When you play with Lego, you take the thing into the smallest piece. Can you still take them apart? The smallest piece, can you split them? No, you can't. Atom is exactly like this. So these are tiny Legos. Tiny Legos. Tiny Lego blocks. Right? So all matter is made up of atoms. So we have all these atoms inside our matter. And atom is the simplest particle of matter. Simplest particle, they are the smallest. Atom is the smallest particle of an element and cannot be divided into anything smaller. Right? You can't split atom. You can actually, but we don't go into that yet. An atom can only be seen using an electron microscope by enlarging the atom to 1,000,000 times. Right? There's no way we can see atom because they're really small. So I think you learned this in year 7 already. So your atom has 3 parts. Have you learned this in year 7? Okay, if you don't, let me repeat this or let me just teach this again. Right, so this is your atom. Your atom has 3 parts. Your atom has 3 parts. Right, before I begin, can you see the middle here? This middle part, can you see the red color and the blue color balls? These are what we call nucleus. Right? Oh, you learn it again, Okay. That means you're learning electrostatic, is it? Because usually when you learn atom in physics, it's when you learn electrostatic. Right, so this thing in the middle is called the nucleus, just like our cell, you see? If this is our cell, if this is our animal cell, the middle part is called the nucleus. Right? The same thing, the middle of your atom is the nucleus. Okay, and then can you see all these gray color balls spinning around? Spinning around. These spinny boys, okay, these spinny boys that runs around, we call them electron. Electron, they are negatively charged. These are all negative. Right? Electron. Electron. You see, when electron, they jump to another atom and they jump and jump and jump, this is how we create electricity. You see, electron will give you electricity. Electron, electric. Electron, electric. Sort of the same thing. This is called 负离子。这个东西叫负离子。That is your electron. Lithium. No, it's not lithium. It's not lithium. You have so many neutrons here. Right, so in the middle of the nucleus here, the nucleus here has 2 things. Okay, you have negative, you must have positive, right? You must have positive, right? So the positive, we call it proton. Okay, proton, they are positively charged. So electron and proton, They are opposite of each other. This is the girl, this is the guy. If you get what I mean. All right, so this is your proton. Okay, your proton. And then there is this guy here, which is neither negative or positive. They are just in the middle. So this middle guy is what we call neutron. Neutron. You know why? Because they're neutral. They are neutral. No, it's not. You don't get you don't get positive nitrogen. Right. So what does it mean by neutral? Guys, what does it mean by neutral? If you have two friends fighting, and they ask you, whose side are you on? Whose side are you on? If you say you're neutral, okay, if you say you're neutral, that means you don't help either one. They can both go to hell. Right? You're siding neither. You think both of them are stupid. So you're neutral. Right? So you're neutral. So again, you have protons spinning around. You have protons spinning around. And you have electrons spinning around. And you have proton in the middle. And you have neutron in the middle too. Right? And this electron and proton, they are always the same. You see, I have 3 negative. I will have 3 positive. Makes sense, right? Makes sense, right? I have 3 plus means I have 3 minus. It works that way. Right? I'm not talking about charge, guys. I am not talking about charge. You will learn charge next year. Okay, in year 10. I'm not going to go into that yet. This is just the basic. So there are many different types of atoms. Scientists have discovered 94 that occurs naturally, while 24 has been made in the lab. Right. So how many types of atoms do we have? Right? We have hydrogen atom, we have helium atom. It's like Lego lah. You have the one with the one dot, you have 2 dots, you have 4 dots. You have many types of Lego. So same thing here. You have many types of atom. Many types of atom. You have 118. Yes, you have 118 elements. You have 118 types of Lego of atoms. 118. Okay, 118 times. So, okay, why am I teaching this? Because let's go to the first one. Okay, this is the first thing we learned today. What is an element? This is called 元素。什么是元素呢？如果它只是一种 atom 做成的，它就是元素。So guys, what is an element? A substance that is made up of just one kind of atom is called an element. Right. For example, carbon is only made up of carbon atom. You know what is carbon, guys? You know what is carbon? Carbon is your pencil lead. So you see, your pencil lead, inside your pencil lead, there's only carbon atom. There's nothing else, right? So carbon, your pencil lead, is an element. 元素. Okay, so you can say it like this. Atom, they become elements. Okay, many same atom together, you get an element, right? Gold is made of only gold atoms. Silver is made of only silver atoms. Carbon, gold, silver are examples of elements, right? You see, this is your gold. They are 100% gold atom. That's why we call them pure gold. We call them element. Same goes to iron. Same goes to iron. You see, there's only Fe atoms here. Fe is iron. Fe is iron. Can you see there's only Fe here? Do you see any other alphabets here? No, there's only Fe. So this is your pure atom. Pure iron. Pure iron. We call it element. So iron is an element. Gold is an element. Yeah, graphite lah. We call it carbon or we call it graphite. Okay, it's the same thing. Right? You guys okay, You guys okay, This is like the most basic. The most basic element has only one type of atom. Right? One type of atom. So some substances are made up of individual atoms. For example, a piece of gold is made up of millions of individual gold atoms. Neon, which is a gas, is made up of individual neon atoms. Right? Some atoms, they like to be together, like gold. Some atoms, they like to be alone, like neon. You see, neon, neon is alone. Neon is alone. Neon is alone. They just like to be alone. They are not like gold, you see. Gold and iron, they like to stand together. Not for neon. Neon just likes to separate from each other. Okay, that's a neon. Most basic example is oxygen. Oxygen is a molecule. I'll talk about that later. Right? You guys okay? You guys okay? So if it has only one atom, we call it an element. You see? Atom, element. One type of atom becomes element. Right? Many students will get confused here. Many students will get confused here, but let me tell you, atom is something that you cannot see. Atom is something that you cannot see. Element is something that you can see. You can see gold, right? You can see iron, right? So this is something that you can see. This is the bigger one. Atom is a small one. Same type of atom, big one, element. Element. You get the point, okay? You get the point. Right, so next, let's talk about molecules. Okay, molecules. Some substances are made up of little groups of atoms, right? A group of atoms joined together is called a molecule, right? Like your oxygen is a molecule this time, right? Because this time you see, atom is one. If you have like, two and above, we call it a molecule. Okay, that's why we say oxygen molecule. Because you see, I have one oxygen atom and another oxygen atom together. This becomes an oxygen molecule, right? Molecule. So atom is one, molecule is many, right? Molecule is many. Okay, and then later I shall tell you, your molecules will become compound. Compound is two or more different elements combined. Right? When you have one Lego and another Lego coming together, you will get a compound. This one later, right? So, in order to make, okay, just now I said we have 118 types of Lego, right? We have 118 types of elements, right? To make everyone's life easy, scientists, they put everything into a table. Right? They put everything into a table. So chemists refer to all elements using symbols. Okay, to make their job easier, instead of just writing carbon, why not just write C? Okay, this is the symbol. All the known elements are arranged in a table called the periodic table of elements. The elements are referred by their symbols, right? Like, you see, all these are symbols. You will never write the full name. I mean, next time in chemistry, you don't. Right? These are the symbols, right? Why symbols? Because it makes your life easier. Okay, it makes your life easier, right? But sometimes it will make no sense, you see. Sometimes it will make no sense. Like if you look at group 1, H is hydrogen. Okay, this one makes sense. Li is lithium. This makes sense too. But why in the world is Na sodium? Okay, why is it sodium? Because the real name of sodium is called natrium. It's called natrium. Why natrium? Because this is a Latin name. Right? Remember our heart chapter? Remember our heart chapter? Remember what is vena cava? Remember what is your aorta? Right? Those names we use Latin. Right? In fact, many things in science we use Latin. Right? I think I told you this last time. Why do we use Latin? Because Latin was the original language of, the Roman Empire. When you speak Latin, it means that you are smart. It is the language of knowledge. Right? So yes, it's very different. Not yet, okay. Chill, not yet. Right. Like for example, interesting stuff. You know what is Ag? You know what is Ag? Ag is silver. Right? Ag is silver. How is Ag exactly silver? It doesn't make sense, right? You are right, it doesn't. Because silver, the proper name is called The Latin name is called argentum. This is the Latin name. Guys, does it sound like a country to you? Yes, right? Because it stands for Argentina, right? It's the land of silver. The Spanish used to go there for silver, right? Yes, and Argentine is for silver ore. Yes, correct. Right? That's why you get the names Argentina or Argentum. But we English call it silver. We English call it silver. So guys, if you think about it, English is a weird language. Okay, English is a weird language. Because if you think about it, you know pineapple? You know pineapple? Did you know all the culture they call it nanas or ananas? You go to Spain, you go to Portugal, you go to everywhere, they will call pineapple ananas. Even BM is called nanas, right? But somehow English just say this is a pineapple. It doesn't look like an apple, but why is it called pineapple? So you see, in English, it makes no sense. Same here, we don't call it silver. It's actually called argentum, right? So guys, do not memorize this. Do not memorize your periodic table. You have no place memorizing this thing. I mean, if you want to go and memorize just because it's cool, fine. I'm okay. But there is no need to. Why are you wasting your space in your brain? You memorize 3 lines. Okay, if you memorize the first 3 lines, it's okay. Because in your A levels next time, you'll be studying this group, this line number 3. Right? For this middle guy, okay, guys, let me tell you something. Let me tell you something. We don't usually mess with these from 3 to 12. From the 3rd to the 12th, is this row or column? Row, column. Okay, from the 3rd to the 12th column, we don't mess with them. We call them transition element. Right? We don't mess with them. We don't study them because they are very complicated. Right? They are very, very complicated, so we don't mess with them. Okay? Very cool. Any elements you want to ask? Any elements you want to ask? Okay, I do have a question. What is lithium used for? Good. Batteries. Very good. Batteries. Okay, your lithium ion batteries. I don't care whether you're using a phone, or you use an iPad, or you use a laptop, or you use a Tesla. Any of you have an electric car at home? If you do, there's a big chance your car uses lithium battery. Okay? But here's the thing, guys. Here's the thing. Everyone in group 1, everyone in the first row, they are crazy. They will explode. That means lithium 2, they will explode. Right? That's why we never really use lithium. I mean, you might say denser. That means our battery will explode. Yes, you are right. Our battery will explode. That's why you heard cases like this Battery, people using their phone halfway, the phone just decides to catch up in flames. That's the reason why. Okay, system is more. Yeah, I know, but we don't mess with this. Lithium is bad enough. Okay, yeah, tungsten is where tungsten is here. We use this in light bulbs. We use tungsten in light bulbs. Okay, understand? Understand? Okay, I do want you to know something though. I do want you to know something. You don't need to memorize anything here, but I do want you to know where is the metal. Okay, or should I say where are the metals? Okay, where are the metals? Where are the non-metals? Okay, where are the non-metals? And these red ones, we call it semi-metals. Why semi-metals? Because they kind of behave like metal, they kind of behave like non-metal. They're like halfway. You see, these are guys, okay, boys. These are girls. These are not boy, not girl. I don't know how you put it. whatever you want to say. Okay, so these are 不男不女. They're like halfway, not a guy and not a girl. So you do need to know where's your metal. Metals are usually on the left side. Non-metals are usually on the right side. I just remember it like this: 男左女右. Do you guys say this? Do you guys say this? 男左女右. Guys will always stand on the right. Sorry, left. Girls will always stand on the right. When you're in primary school, that's how your teacher asks you to queue up. 男左女右 嘛. Right? Usually guys will do things on the left side, girls will do things on the right side. So that's how it works. So metals are the boys, non-metals are the girls. This one easy. All right. So let's look at these points here. Some elements symbols are based on their English name. For example, calcium is represented by the symbol Ca. Oxygen is represented by O. This one easy. Some element symbols are based on O Latin. For example, sodium is known as natrium in O Latin, hence the symbol Na is used. Oh, funny you should mention that. Lead is Pb, right? What is Pb again? Here. Pb stands for plumbum. Pb stands for plumbum, right? Oh, guys, can you see lead here? Can you see lead here? Just to let you know, this is not your pencil lead. This is not used in pencil lead. We usually don't mess with lead because lead is very poisonous, right? If you eat it if you eat it, right? We don't use lead. We don't mess with lead because they are very bad for your brain. If you eat this thing, it will poison your brain. You will slowly become stupid. That's what happens, right? So plumber. Wow, I didn't notice that. Damn. Did you discover this yourself, Carl? Wow, that's very observant. Damn. Wow, my mind is blown. Wow, shit. Hey guys, do you know what is bismuth? Do you know you can buy this online? This is really cool. I want to buy this and put at home, but I don't know for what. Look at this. This is bismuth. You can buy this from Shopee. This is natural bismuth. Natural bismuth looks like this. Don't you think it's cool? Damn, look at this thing. Guys, this is a mineral. This is bismuth. So cool, huh? So cool, huh? Wow, you look at this. Wow, it's like some kind of minerals from the sci-fi movies. Okay, I mean you want to wear it lah. Cool, huh? So that's a bismuth. Right, so about the namings. So next, the periodic table is organized in rows and columns. Okay, please highlight this, guys. Please highlight this. The rows are horizontally. Horizontally, we call it periods. Columns, we call it groups. Okay, columns are core groups. So this is your group, this is your period. Okay, you see, why do we learn this? Why do we learn this? This is easy for you to tell where is something. Okay, for example, where is boron? If your friend asks you, where is your boron? You can easily tell them they are in group 13, period 2. You see, this is your group, right? Vertical is your group, They are in group 13. They are in period 2. Easy? Don't you think this is like your XY coordinate? Your XY coordinate. B is at X axis. Is at your 13, 2. Have you learned this in maths? Have you guys learned this in maths? Right? It's like coordinates, guys. It's like coordinates. So telling someone where is the group and the period is like telling them the coordinates. So that you don't need to say, oh, it's next to carbon. Also, where is carbon then? Right? So you can easily tell them. So these are the groups and this is the period. Okay, guys, okay. I don't know for you lah. Maybe this is very boring for you, but this is very interesting because I freaking love chemistry. I freaking love chemistry. Girls not so much lah. Huh? Girls not so much lah. Is it that case? Is it that case? Renee, do you hate this? I haven't even started on electricity leh. Okay, electricity, you you will puke blood, right? So this is your coordinate. This is your coordinate. Right. Guys, I have a question here. I have a question here. Why is there a gap here? Why is there a gap here? You see this gap here? Okay, I have many students asking me this, sir, why can't we just arrange all these to here? Why do we need to leave a gap here? Oh, you learn contact process already. Wow, so fast. Okay, so guys, why is there a gap here? Why is there a gap here? Okay, guys, this gap is not for fun one. Okay, the gap is not for fun one. I mean, yeah, atomic mass, that's one. But you know why they arrange it this way? You see, the periodic table is arranged in such a way, every group, they behave the same. They behave the same. That means you see, okay, let's say this is did I mention this? Okay, let me finish this and you understand. The periodic table is read from left to right, top to bottom. You read your periodic table just like how you read your book. You start from the top left corner and you read your way to the right and you read your way to the bottom, right? You read it this way, right? You read it this way. So it's just like how you read your book. This is how you read your periodic table. From left to right and top to bottom, the mass of atom increase. You see, as I go more to the right and more to the bottom, they get heavier. They get heavier. So in this sense, right, this guy is the lightest because it's the first one. It's at the most top and the left. They are the smallest. And this guy is the fattest, the biggest. This is a big boy, right? Okay, this is the biggest because they are the most right hand side, they are the most bottom. This guy is the fattest guy. Okay, so you see, you look at the number, you know, this is number 1, number 2, okay, number 3, 4, 5, 6, 7, 8, 9, 10, and you go all the way down, right? They become bigger, 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 bigger as you go down. All right, so elements that are found naturally in Earth's crust. Okay, this one I'll mention this later. So why is there a gap here? Let me explain this. Why is there a gap here? They made it this way. Okay, guys, the scientists they have tried many versions of periodic table already. They have tried many, yes, hydrogen is the big bang one. Okay, they have tried many versions. They have changed this thing to many shapes. But the best way they do it is by arranging them this way. All right. And can you see something? Can you see something? Like I said, guys, we ignore this middle group. We ignore this middle group. And if you don't count the first one, if you don't count the first row, can you see? This is 1, 2, 3, 4, 5, 6, 7, 8. You have 8 elements per row. Just like music. This is what we call the law of octaves. Do you guys learn music? Do you guys learn music? You have C, D, E, F, G, A, B, C. That's an octave. It's the same. This is called the law of octave, right? And the lower C and higher C, they belong to the same family, same C. So same thing here. You see, lithium, right? This is do, re, mi, fa, sol, la, ti, do. Okay, when you come back to here, everyone in group 1, okay, this is group 1, right? This is group 1. Everyone in the group 1, they behave the same. They behave the same. Okay, for example, you see, lithium, I said will explode, right? Lithium will explode, right? So you can be damn sure everyone in group 1 will explode. They behave the same way. They behave the same way. That's why we put them in a group. That's why we purposefully leave a gap here. Because you see, if I put 1 here, and I put 2 here, and I put 3 up here, and I put 4 here, you see, now the arrangement is all messed up. I can't group them together already. But if I put it this way, I can easily say, oh, group 1, they are all the same. Right? Like group 2, you know what is group 2 for? You know what is group 2 for? Group 2, group 2, the second row, the second column, group 2, they produce very colorful flames. They produce very colorful flames. So group 2 is good for fireworks. Okay? It's good for fireworks. So your group 2, right? We all use group 2 for our fireworks. If I'm not mistaken, calcium is red. Calcium is red. I think barium or strontium is green. Something like that. Okay? Like, okay, another example. If you go to 17, fluorine, chlorine, bromine, iodine. Sorry, wait, not the last two. Have you heard of chlorine? I mean, that is just a part of calcium. Okay, do you know what's chlorine? Guys, what is chlorine? Have you heard of this? Yes, what we put in water. The thing in swimming pool, right? We use chlorine as bleach. Okay? What is chlorine for? What is chlorine for? Chlorine is very good in killing germs, right? In killing bacteria, right? So we can be damn sure everyone here will kill bacteria for you. Okay, case in point, Case in point, I is iodine. Iodine. It's the same function as chlorine. Iodine is used for your wound. You know 黄药水? You know what is 黄药水? When you run and you fall down, you get a wound, right? So how do they clean your wound? How do they clean your wound? They will use iodine and they put on your wound. Same function. Your chlorine is to kill germs. Your iodine is also to kill germs. See, same function. Same function. Okay. Bromine, iodine, no, not same color. Bromine is brown. That's why it's called bromine, brown. Iodine is black. Oh, something about iodine. Guys, let me show you something really cool. Iodine. Oh, first of all, guys, iodine is like dry ice. They don't change into liquid. They straight away change to gas. Guys, do you remember what is sublimation? Do you remember what is sublimation? Just like dry ice, they don't turn into liquid. You see, iodine is a black color solid. When you heat it, they straight away change to gas, a purple color gas. Can you see the purple color gas? Can you see a purple color gas? So sort of like evaporation. So they sublimate, they change to gas. And can you see the top that's ice? When they touch ice, they sublimate back into solid again. So you see the black color solid at the bottom of the ice. Wow, so cool, isn't it? You see, I really love this experiment because it looks really cool. Look at this. Look at how cool this is, right? So solid, gas, solid. Okay, solid change to gas because it's hot. Then gas change back to solid because it's cold. So that's your iodine. This is iodine. But usually you don't play with this thing, because chlorine is toxic. Bromine is also toxic. Iodine is also toxic. We don't usually mess with these three because you will die smelling it. But hey, at least it's cool, right? It's really cool. So okay, and as for the last one, okay, let me finish this before I go. Okay, you know what's the last group called? You know what's the last group called? What is the last group called? Okay, this last group, they are called noble gases. Do you know what's the meaning of noble? Do you know what's the meaning of noble? Noble means 高贵. 高贵 is like you are very rich, you don't talk to poor people, you are very noble. They are exactly like that. You see, these gases, they will not react with anyone. Okay? Organism, this one, I don't mention that. Right, so besides the last one, okay, so all these, they are very 懒习 one. They very atas one. They don't speak to poor people. Okay? Neon, argon, sorry, helium, neon, argon, krypton, xenon, okay, maybe even radon. These are, they are very unreactive. You burn them, you put acid, you put alkaline, you do anything to them, they will say, yeah, not interested, right? That's why they sit at the most right side of the table. Cause usually, if you're in a class, those who sit at the back row one, they don't interact with you one. They don't care. Right? They're like the very atas people. So that's a noble gas. Okay, noble gas. You can say that, right? But they are gases lah. Okay, they are gases. Helium is used to fill your balloon. So now you see why helium is used instead of hydrogen. Because you see, like I said, group one, they all explode, right? If you use hydrogen to fill your balloon, they will explode and people will die, right? But if you fill your balloon with helium, helium is really chill. Helium doesn't react, right? So if you fill your balloon with helium, even if you burn it, your balloon will do nothing. Your balloon, yeah lah, it will pop lah, but there's no explosion, no fire, no fireworks, no nothing. They are chill. Okay, so these are the chill ones, right? Can you see this is actually very interesting, guys? Periodic table is actually very interesting. Next year, right? Next year, we will learn the details about it. Now I'm just letting you know for fun. Next year, we'll even learn about the history of this. How did this thing come about? Who contributed in this thing? Okay, we will learn about that one is that one is kryptonite, that one different. Okay, so you'll be learning about, have you heard of who is Dmitry Mendeleev? Okay, this is like music. Okay, like music. So cool, huh? Oh, you know, huh? Okay. So anyway, guys, next week, I'll try to finish this if I can. Okay, there's a lot to go through. Okay, so today's is just the basic, Today's is just the basic, Guys, this is a very important basic for you to get familiar with chemistry, If you can't even understand this, your chemistry, you will have a bad time in it. Okay, so make sure you study this, I'll go into the detail next week. Right, so guys, I hope you learned something new today. Okay, it's really interesting. Next week I shall tell you more details about this. Okay, so next week there's class, again, don't forget to come, although it's a public holiday. If you can't come, make sure you request video. So I will be seeing you guys the same time next week. Okay, have a wonderful Monday. I will see you soon. Right, have a good one. See you. Take care. Bye, guys. Good night. Bye.